wait a little while longer just to see if anyone else comes in.
All right, I'll go ahead and start sharing the slides. So today the lesson is going to be on mean, median, mode, range, and interquartile range. And to start off, mean is another term for average. And to find it, first you have to find the sum of all the numbers in the data set, and you divide that sum by how many numbers there are. So if you have that set on the screen, you would add 2 plus 3 plus 5 plus 6 plus 9 to get 25. And since there's 5 numbers in the set, you would divide 25 by 5 to get a mean or average of 5.
So what is median? Median is the middle number, or like just the middle of the average of the middle of a data set. And to find out, you first list out all the numbers from least to greatest, and then you cross off the numbers on the least side and the greatest side until you have either one number left in the middle or 2 numbers left in the middle. If there's one number left in the middle, that one number left, that's your median. But if there's 2 numbers left, you find the average of those 2, and then that's your median. So for example, if you have a data set 2, 2, 7, 8, 14, 18, 19, and 21, if this weren't ordered already, you would first list it out from least to greatest. Yeah. So then you cross off the numbers from the left and right sides until you only have the middle of the numbers left. So in this case, you would have 8 and 14 left. And since there's 2 numbers left, we find the mean of those 2 numbers, which you do 8 plus 14 divided by 2 is 11.
Okay, so mode is the number that occurs the most often in the data set. And so in this data set, you can see that 7 occurs 4 times, which is the most often. It's more than like 3, which only occurs 3 times, and 2, which only occurs 2 times. Therefore, 7 would be the mode. And sometimes the data set, like there can be no mode, or basically every number is the mode. Same thing, because every number shows up the same amount of times.
And range. Range is the range of the numbers in the data set, and it's basically the biggest number in the data set minus the smallest number in the data set. So for in this example data set shown here, the biggest number would be 25, and the smallest number would be 2. So the range would be 25 minus 2, 23.
And finally, here's the interquartile range. And to find it, you need to get the 5-number summary of the data set, which helps you see like exactly where the elements of the set fall. So that consists of the smallest number, the median, which we'll call x, and then you take the median of the numbers before x. So like basically you group all the numbers before x and then find the median of those. Then you group all the numbers after x and find the median of those. And then finally you have the largest number. So if you take this data set, the smallest number would be 2. And then since there are 11 terms, the median is the 6th term, which is 7. And then you have to find the median of the terms before 7. That's also called the lower quartile. And so you take 2, 4, 5, 6, and 6, find the median, which would be 5. So that the lower quartile of this data set would be 5. Then you find the numbers above 7, which is the upper quartile. And in this case, that would be equal to 12. And then finally, you take the largest number, which would be 17. So in the summary, you can see that the 5-number summary would be 2, 5, 7, 12, and 17. And you use that to make a box and whisker plot. So this lets you see where your data values are. And 25%, about 25% of the values will fall in between 2 and 5, which is known as the first quartile. Another 25% would be between 5 and 7, or the second quartile. Another between 7 and 12, third quartile. And then the fourth quartile is between 12 and 17.
So now we're going to show you some examples of calculating the mean, median, mode range in IQR, or interquartile range. So for this first example, if the number 20 was added to a data set consisting of the following numbers, which would change more, the mean or the median? And if you want to, you can type your answer in the chat, or you can unmute. Oh, we weren't asking about the mode. We were asking about the mean or median.
All right, we'll give a little bit more time for some other answers. Okay, should I go ahead and show the answer then?
Sure. So the answer would be the mean. And that's because the median before adding the number 20 was 12, but afterwards, the median would be 12.5. The mean before we added 20 was 10, and after that it was 11. So therefore the mean had the greater change.
Okay, on to example 2. The 5-number summary of the dataset is 3, 5, 6, 12, and 18. And you need to divide the range of the dataset by its median. So I hope you guys remember how to find range. Okay, in case you don't, I'll give you a hint that range would be the largest number, the smallest number subtracted from the largest number. All right, good. Can you guys simplify your answer down? Okay, good job. The answer is 5/2 or 2.5. That's how I wrote it here. And so you find the range by doing 18 minus 3, and then that tells you that the range of the data set is 15. Then you need to find the median, and the middle number would be 6. So you divide 15 by 6 to get 2.5.
Okay, so given this data set, find the mode of the data set and the range of the data set. And if you're struggling to find the mode of a data set, a good way to do it is just to list all the numbers out from least to greatest in order, because then you can see which number occurs the most often, which is the mode. Remember that there may be multiple modes in a data set. As for the range, it looks like you have identified the largest number as 23, but the smallest number is not 2. The smallest number is 1. Okay, so the answer is the range is 22 because the largest number is 23 and the smallest number is 1. So the range would be 23 minus 1, which is 22. And as for the mode, the number 2 shows up 3 times. So most of you all noticed that got that 2 was the mode, but the number 4 also shows up 3 times. So both 2 and 4 are the modes. Okay. So now we're going to do some more application problems.
Okay, so here, the mean, median, and mode of the data set is the same number. Oops. Okay. Well, we're just gonna
That's okay.
continue on. You could try solving the problem the legit way, or if you didn't see, even better. So yeah, you have that data set and an unknown number x, where you have to find x.
And for this problem, one of the first things you should probably do is list out all the numbers from least to greatest. That would help you to identify what the possible values of x.
Does anyone else have an answer they'd like to throw out? Otherwise, I'm going to reveal the answer for the second time. Okay, so the answer to this problem is that x equals 7. And so as Amy said, the first step should be putting the numbers in order. And that lets you easily see that to be the mode, that x has to be either 3, 7, or 12. And since the median has to be the number in the center, you can already see that 12 is too far off to be the median. And 3 is also a bit far, but 7 is right in the center. So that seems like a likely choice for x. And you can check to see if that's the right answer. So if x equals 7, then you add up all the other numbers plus 7 to get 56. And that would make 9 total terms. So to find the mean, you do 63 divided by 9 to get 7. And that would mean that the mean, median, and mode of the dataset would be 7. So that is the answer.
Okay. So if the mean of a data set with 9 unique terms is 12, what is the largest possible term in this set? And a hint for this question would be that in order to find the largest possible term, you need to let one term be really, really big, and you need to let all the other terms be as small as possible so that other term can be big. That's just a hint.
Yes, all the numbers have to be different. If you see anything that says unique terms, that tells you that all of them have to be different. Okay, actually this question did not specify if 0 could be one of the terms, but so that's an error with the question, but no, it can't be.
And yeah, the answer is 72. And to solve this problem, the first thing we do is find the sum of all 9 of those terms. And to find the sum of all 9 of those terms, what we do is we first multiply the number of terms by the mean of all of those terms, because that gives us the sum. And that's 9 times 12, which is 108. And in order to find the largest possible term in this set, the question doesn't specify any of the terms, which means any of those numbers can be whatever we want. So we're going to try to minimize the first 8 terms. That way the last term can be as big as possible. So in order to minimize the first 8 terms, we just make them be the smallest integers, or like the smallest positive whole numbers, which are 1, 2, 3, 4, 5, 6, 7, and 8. And so the remaining term must be 108 minus the sum of those terms. So that'd be 108 minus 36, which is 72.
All right, next problem. Abby scored an 84, 87, 92, and 95 on her last 4 math tests. If she wants to have an average score of 90 in the class, what does she need to get on the 5th and final test? In this case, no, the scores don't have to be different. Okay, so yes, 92 is the correct answer. Good job. And to find that, so we know the average score she's aiming for is 90, and there will be 5 tests. So you have to multiply 90 by 5, and that tells you that the sum of her score on all the tests has to be 450. And then the scores she already has add up to 358. So you subtract the total from what she already has to get 92. And that's the score she needs to get exactly 90.
The mean diameter of 6 sugar cookies is 3 inches. The mean diameter of 12 chocolate chip cookies is 6 inches. Find the mean diameter of all the cookies combined. answer to this question is 5 inches. Now, first of all, think about it. If you have 6 cookies, which a diameter of like 3 inches, right? And then if you have some cookies with a diameter of 6 inches, how could you get a cookie with a diameter of 36 inches? Just think about that. But yeah, so here's how you get 5 inches. So if you think about it, you have like 18 cookies in total, right? And you know the averages of the individual groups of cookies, but you want to find the total average. A good way to think about this is that if you put all the cookies in like one big line, and then you divide the length of that line by how many cookies there are, that's how you find the mean diameter of the cookie. So in other words, you find the sum of all the diameters and you divide it by 18. So the sum of the diameters of the sugar cookies would be 6 times 3, or 18 inches. And for the chocolate chip cookies, it would be 12 cookies times 6 inches, which would be 72. So in total, there would be 18 plus 72, which equals 90 total inches of like cookie diameter. And to find the average cookie diameter, you divide that by the total number of cookies, which is 18. So 90, which is the total cookie diameter, divided by the number of cookies, 18, equals an average of 5 inches.
Okay. Given this box and whisker plot, what percent of the data set falls between 23 and 37?
And if you can't tell, 23, the number 23 is the first quartile of this range. And the number 37 is the third quartile of this range. So yeah, just think about that.
Okay, you guys all seem to be getting it. The answer is 50%. Because first you have the second quartile and then the third quartile, and in between, inside the box, that would be 50%. Yeah, that's what I just said. Okay, so that's the end of this presentation. So we can do some competitive problem solving. Okay, I just need to exit this. Oh wait, Amy, do you want to share the Alchemist or?
Sure, I can do that. Yeah. Okay, so for this, if you know the answer, just type it in the chat and we'll take the first answer that's typed in there and we'll submit it to see if it's right. And if it's right, then good job. And if it's not right, that's okay. You can try again. Just after, yeah, so yeah. So this first question is, what's the largest prime factor of 78? And some of this stuff may be review from the content you previously learned. The first answer we got was 3. So let's see. Oh, what? Okay, hold on. Whoops, never mind. The problem changed.
Well, the answer was 13.
Yeah, it was 13.
I think the focus changed too. That's why the problem changed.
Yeah. Okay, so it's another question now. So Yan and Camille go to a restaurant. There are 10 items on the menu. And oh shoot, okay, that's not the right topic. There we go. Okay.
Right. I'm going to ask you guys to send your answers privately to me instead of putting it at everyone in the meeting. So if you see the arrow and in the chat that says 2, go down and find my name. All right. And then I will choose the first answer.
Okay, so good job, Shreya. Next problem. What is the greatest prime factor of 99? And remember, you should be sending these answers to Yolanda.
Okay, we have an answer of 11.
Okay. Good job. And of course, it's because 99 is 3 times 3 times 11. So the greatest prime factor is 11. And you can see that this question is from one of the older math counts chapters. Here. What is the smallest prime factor of 1,821?
Okay, our first answer is 3. 3 people said 3 so far.
Good job. And yeah, to solve this question quickly, you can first notice that it's not divisible by 2 because it's not even. But the sum of the digits, 1 plus 8 plus 2 plus 1 equals 12, which is divisible by 3, which means that the entire number is divisible by 3. So the answer is 3. What is the least 3-digit positive integer that has 2, 5, and 7 as factors?
Okay, the first answer is 140.
Good job. And for this, it specifically asks for the 3-digit positive integer. So although the least positive integer would be just 2 times 5 times 7, it's asking for a 3-digit integer. Well, the number must have 2, 5, and 7 as factors. So first we do 2 times 5 times 7, and we get 70. But that's not a 3-digit integer. So in order to get it to a 3-digit integer, we multiply it by the smallest possible prime factor, which in this case would be 2. So 70 times 2 is 140. How many distinct prime factors does 56 have?
The first answer is 1.
Wait, 1?
And then we have All right, it's okay. And we can also try 2, because some people are saying that. Do you guys know what distinct prime factors are?
Okay. And yeah, for this question, 56 would be 2 cubed times 7. And this question isn't asking for how many factors, it's asking for the distinct prime factors. And the distinct prime factors are 2 and 7. So that's just 2 prime factors. How many zeros are at the end of the product? 25 times 240. And a good way to do this is not to multiply it out, but just to notice that in order for a number to have a 0, it has to have a 10 in its prime factorization. And the number of 10s in its prime factorization is the number of zeros. So just throwing that out there.
Okay, we have an answer of 3.
Good job. And this is because the number, in order to count the number of zeros at the end of a number, that's basically how many 10s are in a number's prime factorization. So first we prime factorize 25 times 240. And for that, we get 2 to the 4th times 3 times 5 cubed. And a 10 consists of 2 times 5. So there would be 3 10s in here. So there would be 3 zeros. And these zeros at the end of a number, they're also called terminal zeros because terminal means like end. So end zeros. What is the least perfect square with 3 different prime factors?
One is not a prime, so it does not count as a prime factor. Our first answer is 4. Okay, and second answer is 30. But, okay, maybe we shouldn't put that in. Okay, I want you guys to like look more closely at the problem and remember that it says perfect square.
And when they say 3 different prime factors, I'm pretty sure, I think they mean 3 distinct prime factors, because a perfect square has to have all even powers, all even exponents. And if no one can find it, get it, I can give a hint. So it's asking for the least perfect square. So this means that it has to be a perfect square, right? But it also has to be as small as possible. And it's asking for 3 different prime factors. So you should take the 3 smallest prime factors and then square it to turn it into a perfect square.
Okay, can anyone list what the 3 smallest prime numbers are? Yeah, good. They are 2, 3, and 5. So first, multiply those together and see what you get. And then square that to find the least perfect square. Yep. And so 2 times 3 times 5 would be 30. And you square that to get 900.
What is the greatest prime factor of 3,105?
Remember, it says greatest prime factor. Okay, everyone is saying 5. And okay, someone says an answer that seems closer to the correct answer. It seems more likely to be correct, so we'll go with, okay, no. Take your time.
Remember that for this, try to find the prime factorization. And it's obvious that 5 is one of the prime factors of 3005. So you first, like, if you're trying to find the prime factorization, a good start would be to divide by 5. And then that would get you 5 times 621. And then you would need to continue to prime factorization that until you have all primes.
Okay, someone says 23.
Good job.
People said that, so good job.
23 is the correct answer because 3,105, you can first divide by 5 because that's the obvious prime factor. And then you get 5 times 621. And if you notice, the digits of 621 add up to 9, which is divisible by 3. So that means that 621 is divisible by 3. And actually, it's divisible by 9. So if you do 621 divided by 3 times 3, you would get 5 times 3 times, the total prime factorization would be 5 times 3 times 3 times 23. So the greatest prime factor would be 23. What is the positive difference between the greatest and least prime factors of 2000? And again, for this one, oh, you can go.
Okay, so after this, we should probably change the focus to something else. Like maybe order of operations, something else that we've gone over to get more practice.
And yeah, and for this problem, again, you should probably prime factorize this. And it might look like a big number, just 2000 looks kind of big, but it's not actually that hard. So
okay, we have an answer of 3.
Good job. And to solve this problem, 2000 is 2 times 1000. And 1000 is just 10 times 10 times 10. So the prime factorization of 2000 would be 2 times 2 times 2 times 2 times 5 times 5 times 5. So that would be 2 to the 4th times 5 cubed. And so since the only two factors are 2 and 5, the difference between those two is 5 minus 2 equals 3. And now we're going to switch topics. Okay, we're going to do order of operations. what is the simplified value of of 7 to the 4th times 8 minus 2 cubed plus 11 to the 4 times 8 minus 32 power?
Okay, we have an answer of 1.
Good job. So for this, first notice that you don't need to actually calculate out this whole thing because that would be a little bit hard. So 7 to the 4th is a big number, but 8 times 2 or 8 minus 2 cubed is 0 because 2 cubed is 8. So 8 minus 8 is 0. So 0 times 7 to the 4th would just be 0. So this entire area, this entire term would just delete basically. And then for this, 11 to the power of 4 times 8 minus 32. 4 times 8 equals 32. So 32 minus 32 is 0. So this term would just be 11 to the 0. And if you remember your thing about exponents, anything raised to the 0 power is just 1. So this whole thing would just be 0 plus 1 equals 1. Okay, find 1,421 divided by 7 plus 47 divided by 50 times 9.
All right, our first answer is 45.
Good job. So the first step in the order of operations, PEMDAS, is the P, so parentheses. So first we're going to look at the parentheses. And next we should look at the multiplication and division. There's no multiplication here, so just look at this division sign. So we would first do 1,421 divided by 7. And that equals 203. So that simplifies to 203 plus 47, which equals 250. So now our whole parentheses thing equals 250. So we have now 250 divided by 50 times 9. So now we work from left to right. 250 divided by 50 is 5. And then 5 times 9 equals 45. That's the answer. Evaluate 5 times 11 squared minus 3 times the quantity of 2 to the 4th minus 4 divided by 2 times third close quantity. remember for this one, you need to start in the parentheses and then the exponents and then multiplication, division, then addition, subtraction.
Okay, we have an answer of 579. Okay.
Okay.
So where are you guys getting stuck? Does anyone want to say? Have you guys figured out how to do the parentheses? And is it some other part that's confusing? You can unmute and say if you want to.
If not, we can just walk through the whole thing.
Yep.
Okay, then I guess I'll just go through the whole problem. So first, in PEMDAS is the P, so we look at the parentheses. And next on PEMDAS is the E, which means exponents. So first we look at inside these parentheses, we have the exponent 2 to the 4th power. So first, we're going to simplify that. So 2 to the 4th power is 16. So now the parentheses would become 16 minus 4 divided by 2 times 3. So now we look at multiplication and division, but we look at it from left to right. So 16 minus 4 divided by 2. So first, this division sign is going to go. So if we were to simplify, it would be 16 minus 2, because 4 divided by 2 is 2. So 16 minus 2 times 3. So now we look at this multiplication sign. And if you don't know, this dot is a multiplication sign. It's just a more fancy way of writing it. So now it would be 16 minus 2 times 3. So if you do the multiplication, it would be 16 minus 6 within the parentheses still. 16 minus 6 is 10. So now we have 5 times 11 squared minus 3 times 10, because the parentheses we've evaluated to 10. So 11 squared is 121. So yeah, we simplified the exponent. So 5 times 121, that's 605. So it would be 605 minus 3 times 10, which would be 605 minus 30, which would be, I'm pretty sure it's 575, if I'm not mistaken.
Yep.
Yeah.
Someone did send it to me.
Yeah, some of you were a little close. So yeah, this is just the thing I said, except it's written out in a way you can understand.
Okay, so it's almost 6 o'clock, so I'll just go. I'll just tell you the list of who got the questions correct first. And sorry if I mispronounce your name. So Shriram got six questions. Venkata got 2. Gauri got 1, and Sanjay also got 1.
So yeah, good job, everyone.
Yeah. So for these, whoever does the best gets an extra credit point to the standings, I believe.
Yeah.
And the quiz for this week will go up at 6 o'clock. So make sure you guys finish that.
And yeah, I think that's all for today because we only have 3 minutes left. So
Thank you for coming. Yeah,
Yep.
feel free to leave now or stay if you have a question you want to ask.
Also, please fill out the feedback form.